video, we'll discuss what type of correlation coefficient you use when you have a curvilinear relationship. So what does this form look like? Here we're looking at GNP per capita and life expectancy. Now, if you were to do a Pearson's correlation, you're not going to get a very strong relationship because it kind of goes up here and then it tapers off. How would you describe this? It's called a curvilinear relationship. Now, how about this? This is looking at performance, the amount of anxiety, moderate and high. Does this look like it's a linear relationship? Linear would be a straight line. Does it look curvilinear where you have kind of it goes up and then it kind of tapers off? It's nonlinear. So we can't do a Pearson's correlation or a Spearman's correlation with this type of data. We would have to use another type of analysis. So when do you use a Spearman's correlation? So one way would be is even if we had a linear relationship, if both variables were measured on an ordinal scale or in ranks, so here your X scores in ranks like first, second, third, fourth, same thing for here, Y scores are first, second, third, fourth, you would need to use a Spearman's correlation. In addition, when the interval isn't linear, but might be consistently one directional, and so that's that curvilinear type of relationship, where you see this relationship and then it kind of tapers off. And a lot of times you see this with dose responses and drugs and things like that. So when you have nominal data, so both variables are non-numerical, you're going to evaluate it in a matrix. And so you can't use either the Pearson's correlation coefficient or the Spearman's. You're going to have to do what's called a chi-squared test. So you look at categories of one variable and form the rows, and the categories of the second variable form the columns. And so what happens is you compare what your measured proportions are to what your expected proportions are.